Hello everyone. I wanted to make a quick video for talking about microservices, introduction to microservices. Microservices kind of the latest architectural style out there. There's a lot of job offers out there. There are a lot of positions in the market expecting the candidates to know about microservices and what exactly are these microservices and how are they different from traditional APIs? That's kind of what I want to hit on in this video, right? Hopefully, it's not too long and not too boring, and it's just gonna gives you nothing super, like we're not getting into coding or any technical aspects or anything like that, but just like an overview standpoint of why is industry going. Why is industry embracing a microservices architecture style? That's kind of what I want to hit on, right? First off, microservices is an architectural style, but sometimes you could also have a different meaning to microservice. Any service that is small enough that handles a single capability or single responsibility, you can also call it just a microservice. It doesn't mean that you have a full-blown microservice architectural style. You just have a system that contains one or two simple microservices, and both of them are working together to provide the overall functionality. And that's also completely possible. That's not truly a microservice architecture style, but microservice architectural style means that you have it's a specific pattern. You just try to understand what the domain of what you're building, by talking to the domain experts, identify the business capabilities and technical capabilities, and then you assign each microservice a single business capability. And so business capabilities are different than use cases, right? Use cases are something like you want to do something, right? For example, I want to create an invoice. I'm talking about maybe a simple e-commerce based application. You want to create a final invoice. Then for that, you have to rely on multiple business capabilities. Like you have to think about special offers, think about, any coupons, you think about the actual subtotal and the taxes. And, all of these capabilities will be combined to create the final invoice, for example, right? Create invoice is a use case. But to deliver the use case, you want certain business capabilities, right? So the main point that I want to drive here is that business capabilities are very important to understand, to create the business capabilities, or to even to understand the business capabilities. They're very essential for microservice architectural pattern. And how do you understand the business capabilities? You basically understand them by talking to the domain experts, right? Because when you start a greenfield project, you want to gather as much information as possible about the project by talking to the stakeholders, by talking to the subject matter experts. Talk to these people, try to pay attention to the language they're using. They use certain words over and over again. You got to keep notes of those words, and that'll paint a picture for you, so that you can draw the business capabilities directly from talking to them, from the end users, from the business stakeholders, from the people, from the customers who have used certain products like that before. From a group of meetings with all these people, you will figure out what the business capabilities are, right? But before we get into business capabilities and in starting to assign a single microservice to a business capability, first of all, I want to talk about how do you even start a system, right? Do you always start with the microservice pattern, or do you start somewhere else and slowly evolve to a microservice pattern as the system grows to a point where it's unmanageable to have everything in a single process? That's something very important. So my recommendation is that don't start directly with the microservices architecture, because microservice architecture is complicated. It's not for simple projects, right? If you're doing a simple to-do list, if you're doing a simple planner application, if you're doing a scheduling app, if you're doing something simple like that, I don't recommend microservices, because it's an overkill, because you have a lot of different components in the microservices, a lot of individually deployable pieces in microservices. It gets a lot complicated to set up the CI/CD pipelines, to set up the scalability. If you don't need that extra extra juice, if you don't need that extra complexity, don't just do it right off from the bat. So always start as a single process application, right? So you have a single API that is serving up the full-blown use cases for the system, right? Now, just because you have a single API, it doesn't mean that you have a bad architectural style. If you have a bad architectural style, then it becomes extremely hard to later separate that single API into multiple services, because everything is tangled up. So you want to make sure you follow a clean architecture process. Right, there are different architecture styles out there. You can follow Robert Martin's clean architecture patterns to how to create your APIs from scratch. There's also iDesign, for example. Yuval talks a whole lot about iDesign patterns, how you can layer your application so that each layer is responsible for a specific capability. Down the road, these layers could be their own microservices, But anyway, I'm not going to get into that. But the main point that I'm trying to say is that don't always start with the microservice architecture, because it might be very costly. You need more people to manage it, and if the requirements don't dictate such a complex architecture, don't go for it right away. Okay. Next up is imagine that you do have something very complex, right? Because that's the whole goal of this recording, is like when you have such a complex requirement. Let's say you're building something close to Netflix.com, or building something close to Amazon, or if you have such complex e-commerce, or anything like that, then obviously you have the need, let's say you have to have 10,000 requests coming in per second. You have such a large requirements. In that case, the first thing you got to start with is, like I said, business capabilities. Business capabilities is not something developers can go code right away, right? As an architect, you got to figure out, if you're in the architectural role, you got to talk to the domain experts to understand what the domain is all about. And you got to talk to the stakeholders, like I said, to identify a list of business capabilities that make up the system. That's the first step, right? And then you assign each microservice to that domain capability, business capability. So that's kind of how, and in later videos, I'll talk a whole lot about business capabilities. There's also technical capabilities that the end user won't see, but they actually facilitate the business capabilities, one or more, right? And they're also individual replaceable, right? So once you identify the business capabilities, then basically the idea is that you have one microservice per business capability. Next up is, we need to understand first, what are some of the characteristics of microservices, right? At least I can think of 5 characteristics of microservices that you have to keep in mind as you design the microservices, right? The number one thing is they should be individually deployable, right? So deploying a single microservice should not impact any other microservices around it, because they're all communicating with each other using the contracts, right? So when you deploy, you don't have to hey, this microservice is going to be deployed in the next 5 minutes, so I need to take the other service offline because that cannot function without this. So that's that sort of tight coupling. You have to try to avoid that, right? They should be individually deployable, and they should have their own database, right? So the data, whatever business capability that microservice is supporting, that the data related to that capability is stored in its own data store, whether it's a relational data store or a non-relational data store. That's a different matter, because database, if you look at Robert Martin's architecture style, he calls database as a detail. You don't need to figure out up front what that structure is going to look like. You can just stub it out. Don't worry about that. Create those interfaces first, and you can implement them later. But when you design it, whatever may be the style, if it's a relational, non-relational, each microservices has its own dedicated database, so that the capability, that particular domain of objects that they're handling, they're stored in that specific database, right? And in other microservices that comprise your full system, they don't have duplicate data, right? If, for example, let's say you're talking about a product catalog, right? So a product catalog microservice will have a list of products, right? They're all ID'd, and there are different products and prices and stuff like that. So that information only exists in the database of the product catalog microservice. If you go to the invoice microservice, you're not going to find that. Okay, invoice microservice relies on the product catalog to look up the product for validation and stuff like that, but it's not going to calculate. It's not going to know the SKU or anything like that of a specific product. So there's no duplication. You got to make sure you segment the data in such a way that, we talk about scoping of microservices. It's a whole other concept. There's concepts like widely scoping, narrowly scoping. We can talk about how to right size the microservices so that we're not in trouble later. That's a whole nother video that I'm going to make later. But the point here is that each microservice will have its own database to support. Next up is it exposes an API, right? So microservice by definition, it runs in its own process. It has a set of endpoints it supports, and it's basically accessible via HTTP, right? So HTTP, as you guys know, is widely accessible by single page applications, by other mobile applications, traditional applications. Even if you build apps for the TV, for your fridge, for your IoT devices, HTTP its accessibility of HTTP is huge. So that's one of the benefits when you design something for HTTP or /web, right? Because your reachability is much higher in HTTP. APIs. So each of these microservices are available over HTTP, and they're basically APIs, and they have a set of endpoints that the APIs support. So that's another thing you got to keep it when you use each microservice is basically an API, right? And I think that's pretty much it. So as long as you're taking care of these, like I said, each microservice supports a single business capability, and they're individually deployable, and they support their own database. And you can deploy the microservice without impacting other services that rely on that microservice. And they're fundamentally they're APIs that have multiple endpoints that support that single business capability. And if you have these, I think that qualifies for a microservice. Right. Next up, I want to touch on CI/CD. I'm not going to get into details about the tooling and all of that, but continuous integration, continuous deployment are huge for microservice architecture. Not only for microservice architecture, even if you have a monolithic style of application architecture, you still need CI/CD process, because nowadays, you want your developers to spend most of their time writing business logic, writing application logic. Save them from things like setting up pipelines and deployments and approvals and stuff. Well, that's not their concern. So just automate that process as much as possible, so it's very much streamlined, and you guys the developers can they can spend the time doing what they're hired to do, as opposed to doing all the other cross-cutting concerns like figuring out the security, the tokens, and the pipelines and stuff like that. That's my style, right? Some other guy, it could be a lead or could be an architect, who can step in and figure out those cross-cutting concerns, while the developers can focus on the core business logic and start churning out features. You know what I mean? So next up is scalability. Microservices, the whole idea of microservices is each of these services can be scaled independently, right? So let's say that a certain, you probably felt this in a monolithic style. There might be, like, let's say that you built a traditional application, even if it's a single page application, you might feel that a certain component of the application is getting a lot of hits. the users always want to land on that page. The users always want to do their transaction. If you look at the analytics of the application, you can see the amount of time the users spend. If you assign percentages to the amount of time they're spending on each of the pages, you might figure out that, hey, this is the one page that is the most important part of our application, because that's where a lot of the users, they sign in and jump right to that page. Some people even bookmark that page and they don't even care about the rest of the application. That's the important page that's helping them, right? So when you divide such an application into microservices, then obviously that microservice that's handling that business capability, which is driving most of the users' attention or time, that needs to be scaled higher than the other microservices, because it's expecting a lot of traffic, right? It's getting a lot of requests per second, so it needs to be either scaled horizontally or vertically, depending on the use case, right? So that's around scalability. There's a lot to discuss about scalability. A lot of these are usually, if you choose a cloud provider to host your microservices, there's tons of options depending on the cloud providers you choose, and also the type of deployment options. There are multiple options. You can deploy the services in apps. So for example, we're talking about Azure here. If you use Microsoft Azure, then you can use app services to deploy your APIs, right? Or you can use containers to deploy your APIs. And you can put in a container orchestrator on top of it, like Kubernetes or something. So there's tons of options to deploy and manage your microservices. So depending on whichever option you pick, the scalability is available for those options. Next up is from an end user perspective, right? So a single microservice may not drive the end user capability, like the use case, right? So sometimes you might have to take a combination of microservices. Microservice A plus microservice B may satisfy a single use case, right? It's not like a use case is equal to a microservice. A second use case is equal to a second microservice. It's not like that. Sometimes the example that I gave earlier, create the invoice for this customer may include price calculation, tax calculation, product catalog lookup, applying coupons, promotions. So there's a whole bunch of logic embedded in it. And you got to identify, based on the scoping scenario, this might include more than one microservice to satisfy a single use case. So from an end user perspective, a single use case may be equal to a combination of microservices. It's giving him the final functionality. And the last I have here is communication between microservices. Communication can happen. Usually there are two common ways to communicate between the microservices. There is a request response, which means that you use simple HTTP GET, put, post, delete type of verbs to communicate between the microservices, right? And this is usually synchronous in style, right? That means you fire off a request and you wait for it to respond back, so you do your job, right? So this is one way of communicating. And sometimes you could just use this for simple things, right? And sometimes, a lot of times, you can also use event-driven approach, also called as asynchronous style of communicating between microservices, right? This is kind of like a publish one time and you can have multiple subscribers to that, because you don't have to wait for the subscribers. You don't directly communicate with the subscribers. You publish a message or an event, right? When you raise an event, all the other microservices that are interested in that event will subscribe to it. The publisher doesn't care about how many subscribers are out there and when they're subscribing, if the message is pulled by them or not. It's completely disconnected, right? It is a disconnected style. It's asynchronous, right? So there's that style as well. It all depends on the scenario. So you can use, it's not one or the other way. It doesn't mean a single microservice architecture for a project doesn't have to be all event-driven or all synchronous like HTTP request response. You could use a hybrid approach. Some scenarios use a synchronous event-driven approach, while some services would rely on a simple request response. And I also want to talk about .NET Core. So from a technology standpoint, .NET Core as a platform helps you build microservices very easily. I'm sure you can use Django and Python to build APIs as well. You could use other platforms as well to build microservices, but I come from a background of .NET, so I'll be talking more about how Microsoft .NET Core can help you build microservices very fast, right? Because I'm up to date with what the platform offers. So I'll basically talk a whole lot about how easy it is to spin up microservices using the .NET platform and how it helps with some of the cross-cutting concerns like authentication, authorization, identity provider, and some of that stuff. We're going to talk as I make more videos about microservices. I want to talk a whole lot about how .NET helps with building microservices. And also a note, finally, about Kubernetes. I'm going to be talking a whole lot about Kubernetes as well as a container orchestrator. Kubernetes is fundamentally a container orchestrator. First, we need to create an image using what we use is, in my method, we use Docker Desktop. So at some point, I'm also going to have tutorials about how to install Docker Desktop on your laptop, on your Windows machine or Mac. And I'm going to use Windows, but you can look up the tutorials on how to use the same thing on a Mac. By using Docker Desktop, it's so easy to create images, right? The images and pump the container with the image and keep the container up and running. And you can map the ports. If the container is running on port 80, you can also ping the container using a browser or a Postman or something by using that port mapping and all that stuff. So we're going to talk about all of that as we talk more about microservices. So basically the point here is that I'm going to be using Kubernetes both on localhost and also on AKS, which is Azure Kubernetes Servers. I'm not going to go into depth like what are pods and how many pods you should consider. Should the database be in its own pod versus a single pod can have both the database and the application. Some of those I'll leave it up to you to decide, but I'm going to just touch on implementing the patterns and stuff like that. All right, thanks for listening. Tune in for more.